Hey, so my name is Dayton Taylor, and this is my office or studio in Vernier. I do a lot of work with cameras. Here you can see 100 cameras. And I make my own hardware. So this is a camera controller that I made as kind of a first prototype. And then these are 100 more controllers that I made. And these are more integrated. So I have a company called Digital Air Technologies, and we make visual effects using large arrays of cameras, like up to 100 or more cameras. And if you're interested in that, you can check out digitalairtechnologies.com. Because of the business, I've learned over the course of the last 30 years that I've been running the business, how to specify software to actual software engineers. And because of those experiences, I've gotten pretty good at specifying what I want, because it costs money to work with outside developers, so you have to be very specific about what you want the software to do. So with Claude, I was finally able to kind of realize everything I wanted to do with the software for those controllers. And I have a little demo I want to show how I developed the software. So this is 3 of the camera controllers and 3 cameras. So part of the software is triggering. So this is a laser trigger. This is a motion trigger. There's a sound trigger. And then the software can control the cameras, but it can also control things like lights. So this is just a little DMX switch, which is gives you control over. This is actually just hooked up to relays, but there's also that same language can also turn on lights like this, studio lights. So first I'm going to navigate to the NAS and mount it on my Macintosh, and then I'm going to use this thing called VNC, which is Virtual Network Computer. So this allows me to go onto the desktop of this computer. This is camera number 1's controller, and it's a full Linux computer there. And so this is my Macintosh desktop, and then this is actually the desktop of this. So I wanted to start by just saying that I use the web interface for Claude. You can just go to Claude AI and experiment with it for free if you're interested, or you can pay $20 a month is what I pay to have a pro license to use it. So this is a historical instance, just so you can see. This is probably a few months ago. Unfortunately, it's not dated, but this is where I began writing this software. So what I did was I created in Adobe Illustrator, I created a series of images of what I wanted the graphical user interface to look like. So this is the actual software and what resulted from this conversation. It has 9 pages of controls and settings, and it's quite insane. But it all started with this prompt. Hi Claude, I'd like your help coding a Python 2.7 compatible app called Camera Control .py. It has 9 pages with a list of page titles on the left side of the app for navigation. I've prepped detailed instructions for page 1 in the attached Markdown document, Camera Control GUI Markdown, and Camera Control page 1 SVG. I've also attached PNG renders of all 9 pages so that before you start coding, we can discuss your ideas about how to best implement the page navigation. The app should be blah, 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 wide and height. I'm also attaching a Python file called directional momentary widget that contains a Tkinter template that you and I developed in a previous chat that shows how I'd like to implement the get and set buttons. Also attached are Python scripts for console and CC control Pi that make up the logical framework that the Camera Control Pi GUI will sit on top of. Okay, so this is what I wrote for it to and attached to that first prompt. It tells it that it's a camera control system that runs on a network and synchronizes camera and camera settings across the network. There's several scripts involved. These are the kind of embedded scripts that run in the hardware. And then I just went through and wrote all my notes about what the elements were on that page I just showed you. So that's a pretty serious prompt in terms of like, it's not just saying hello and I'd like you to write some software for me. It's very specific. It took me probably 5 hours or more to write the prompt. But with that, the AI just starts reading all that stuff and then comes up with a plan, a structure, asks me if I want to start with page 1 and use it for as a template for the rest of the pages. And then I answered that. But this is kind of insane, just the length of this is a prompt, one of my responses to its questions. So if we go back to the software itself, it has 9 pages, and the first page has a list of user-authored commands. So these are like macros. Like if any of these can be hundreds of lines of code, and you select what you want to do, and then it enters it into this box, and then you click this button, and it will execute whatever that script is. So that allows me or a user of the system to create complex macros that control everything, or control all the things that you have control over. So on the remote control page, these are not just images of the camera controllers, but they're actually functional digital twins. The camera controllers have these buttons, and when you push them, the display goes through this sequence of display outputs. And when you click the buttons on the digital twin, the same thing happens on the actual display of the device. And then same with the remote. This is a feature on the remote that will blank the display. So if I press it again, it'll turn off all the LEDs. So if you're working in a dark studio, this will make it so that there's no light emitted from any of the camera controllers, because 100 LEDs can light up a dark studio. And then we can continue, turn it back on. And then if you have motors attached, these pads will allow you to pan and tilt the motor. Or you can pan and tilt the motor with these controls. And this page does DMX control of up to 12 channels of lights. And these don't have to be lights. You can also just attach relays to the controller so you can turn on and off any kind of mechanical props or whatever. So you can set your levels and actually control the lights with these settings, and then when you arm it, it will do what you've pre-programmed when it detects a trigger event. And then the sensors are, there's a software for a motion sensor, which just detects any kind of motion. A laser, the laser will detect a broken laser beam between a sensor and a receiver. And the sound sensor detects sound, and you can set a threshold, so if a sound reaches a certain level, it will trigger. And that can be set to trigger either stills or video according to these buttons. And then there are 3 additional cells here where you can enable local AI image processing devices to monitor the system and then run user-defined macros. So that's something that the point of the whole system is to give actually the control of the camera array over to AI, and have the AI understand the software and have all the hooks to be able to operate it, and also to help program these local AI devices to detect certain scenarios and then do things with the camera system according to those what it's detected. So it could monitor like several people talking and make decisions about cutting or edit decisions that are integrated into the post-production process, or pan and tilt and zoom settings or focus settings or whatever based on what it's seeing through these AI-enabled machine vision devices. Another part of it is in order to trigger a sequential array of cameras, the typical thing is just to take all the pictures at once and create a frozen moment, but you can also do slow motion. And because you can do slow motion and frozen moments, you can also ramp between the two so that there's motion that slows down gradually and freezes. So this section allows you to control the curve of the ramp from motion to stop motion or vice versa. And the way it works is you just set your curve, the shape that you want, tell it the in and out point for the number of cameras. I'm going to clear this first. So we could go 1 through 50, 1 through 50, starting at 0.04, which is 25 frames per second, ending at 0, which is frozen moment. Generate those numbers, 1 through 50, and then you can put in 51 through 100 and invert this to get the other half of it. And then generate that, and that appends those points to the overall file. The curve generator, having designed that curve with 100 points on a 100 camera ramp, on the controllers we have a curve visualizer program that allows you to visualize the total curve once you've built it up out of elements. So this could do whatever, straight lines, curves, up and down, whatever you want, and you construct it sequentially the way I showed here, and you can visualize it here. And those ramps can be done for the frame per second or for zoom controls. So these zoom controls are just measured in seconds. The amount of time that you are basically telling the camera to zoom in. So you can all the cameras start zoomed out, and you can make a ramp that over the course of X number of cameras, it starts zoomed back and then it zooms in to full zoom or whatever. Same principle, but it's applying to focal length instead of frame rate, the delay between the cameras. And then this is a third thing, which is the exposure. So for exposure, the ramps, in general, you want your exposure to stay the same, even if you're ramping your shutter speed. So something that we've done a lot in the past is do long shutter speeds. And if you want to start with a short shutter speed and end with a long shutter speed, you have to compensate for that with the aperture going in the opposite direction. So I'll just show you quickly what this calculates that. Oh, let's go 1 through 96. Let's clear the old list. So this has the ability to tell it that the cameras are going to be set up in bulb mode, which means that their shutter speed is actually controlled by the pulse from the controller. But I'm going to create a ramp now just by hitting generate file. And then I can load that, and you'll just see that there's a slightly more complex. So this ramp is, you have the shutter speed getting longer, the blue line, starting at 1/250th of a second and going up to 6 seconds long. And then to compensate for that, you have the aperture going from wide open to f11. And at the same time, you have the ISO, the ASA going from 3200 to 80. Now, the reason it picked those numbers is because that's what we set here. But this allows you to visualize it, and then you can make sure that it did what you wanted it to do, and then you can immediately open a script that will trigger the cameras that will do what's in that profile if you have 96 cameras like these setups. Yeah, so again, the AI also helped me design that. And then the craziest thing is, this is something I always dreamed of doing, is having the AI, having software that would also visualize exactly what the shots are going to look like. And so this is software this is actually on my website, Chemetric.com. You can just go there and play with it if you want to. But basically, you can load the software with these ramps, and then you see what the ramps are, and then this viewer shows you what the results are going to look like. And you can see here, this is the cameras are set up in a 360-degree arrangement. And then the shot, it looks static, but it's actually, rotating around the figure. So this is the shot that you'll get, including the slow motion and the ramp of the person turning into a frozen moment. And then you can also change the degrees of the arc. I'm just going to type in 120 to something that's not a 360, and it adjusts the distance and everything between the cameras, and then it'll show you how that looks different from a 360-degree array. So I think that's it for this software. You can hide the controller, you can hide the graphs, and you can change the height and the tilt on the cameras and stuff. But this is written in JavaScript, which is a language that I don't know, but I had Google Gemini write it, and then I worked with Claude AI to refine it and get the user interface the way I wanted it, add features, move things around. But JavaScript is similar to Python, which I do know a little bit, and Python is what the other stuff is written in. So the other thing about this is that inside of these camera controllers are FPGA. And the FPGA is a field programmable gate array, which is a very high-speed device. So there's a computer that processes programs and code, but then it also sets settings in the FPGA. And the FPGA is so fast, it's like the speed of light of electrons flowing through silicon. So once you set the state of the FPGA in each controller, the FPGAs can trigger one another, and you can have events that basically take place with perfect synchronicity or with perfect delays. And the whole FPGA system has all these registers with delays in it, timers and delays here, and then you can route signals. You can route the signal from a sensor to the trigger input on the first camera, and then you can send the triggers down the line of the controllers through a hardwired link between the FPGAs. And this is a place where, in the app, where you can see what the registers are currently set. You can see what their default, if they differ from their default setting, they're marked in pink. And then you can actually set them here, these particular registers. And then there's a set of all the registers in the system that this is read-only, but this is a numerical list of the same registers plus some that are read-only, and that I didn't have the space for the controls on the other page. But this is so you can take a look at as you're writing these macros that I explained on the first page that do complex sequences. As you're writing and testing them, you can look here to see what the state of the FPGA is at any given time. And then you can also use this other tool that the AI wrote, which is an actual live real-time monitor. So when you do a sequence or an event like trigger event with the laser, you can see, and then when I trigger it, you see them change. So if you're writing the macros again and you need to see what's happening in real time, that helps you with that. And then there's a system page here. So if you have 100 cameras in an array, there are LEDs on them that tell you what they're doing, but you can also look at this to see what's happening. All right, so that's it. In summary, the total lines of code behind all this that I wrote in the last 3 to 5 months was about 40,000 lines of code. The total cost in AI fees was 5 months times $20 a month US, so $100 US. And I think if I had done it through the conventional working with outside software engineers, it would have cost between $500,000 up to maybe $2 million. I hope that the software looks simple on the surface, but it's actually quite complicated underneath the GUI. For example, the sensors page, which are those 3 cells, the laser, motion, and sound sensors, is almost 7,000 lines of code. I know software engineers are going to hear that and they're going to be like, that's way too much, but it's actually much more complicated underneath than you can imagine from looking at the user interface. The other thing is it's going to enable me to invite Claude onto the system and control it itself, and also develop it further. As the AI improves, it's basically going to become a tool, I believe, that you'll just be able to talk to and tell it what you want to do, and it's going to understand all the software techniques necessary to do that. So I think that's kind of the future in general for software and hardware. Obviously, humanoid robotics are going to be doing the same thing on a much more complicated level than this. But what's cool about this is that it's my own thing. It's like an expression of the concepts that I developed over my career, and was able to put into my own hardware that I designed, and enable it to be used with generic AI that understands all the way the system is working. And I think that's going to be a really interesting project for me going forward. Anyway, take of that what you may. I can't imagine how much this technology is going to transform every industry, but software is already mind-blowing. Thanks a lot for watching, listening. Thanks.